Good morning. This is reading week 13 for Physics 2211. This week, the main physics idea was continuing angular momentum. The first video essentially summed up what we had learned so far about angular momentum this semester, talking about how it's similar to the momentum we learned about earlier in the semester. Change in angular momentum is equal to net torque times delta t, similar to how change in momentum, and I'm just going to refer to the normal momentum as Newton's momentum to help distinguish when talking, because without seeing the vectors written out, it's getting kind of confusing. Is equal to net force times delta t. There's also an update formula for angular momentum, and that is L final equals L initial plus torque net times delta t. And the video did an example with a mass on a rigid rod rotating about an axis, and mentioned a couple things to note in systems like these. So when the rod is rigid, that means r per magnitude does not change. And if it's moving at a constant speed, meaning the p magnitude does not change, we can determine with the combination of these two things that the angular momentum is constant. And this can greatly simplify problems, as I think those are relatively common bits of information given in problems, so it just helps speed up the process of doing it. And the video also did an example of a problem in which we need to use the angular momentum update formula, so that was helpful as well. So the next video discussed multi-particle angular momentum, and after working out a problem with the video, it was revealed that the sum of the internal torques in a system is zero because they cancel pairwise, and these are Newton's third law, reciprocity, so it's like a nice throwback. Furthermore, the multi-particle angular momentum principle is just the exact same as the regular principle, but there's just the addition of system notation underneath the L vector and the tau vector. And the next big concept was that total angular momentum is the sum of the translational angular momentum and the rotational angular momentum, which as a whole was kind of expected. I'm not really sure why, but I feel like I knew that. I don't know. There was also an additional factoid that for rigid motion, L rotational equals I, the vector omega, which helps simplify problems. And I refers to the moment of inertia, which we've talked about before. And after that, there were some more examples with the last bit of info that L total, L trans, and L rotational do not all have to be in the same direction. I'm glad they told me that because I would have been kind of confused otherwise. But in terms of what I already knew, I knew the angular momentum was similar to Newton's momentum, and the angular momentum was equal to the net torque times delta t from last week. I did not know the difference between L rot and L trans. I didn't realize there was a difference last week, so this makes everything spicy. But that's definitely a new thing. The most difficult part of this week's content is probably going to be the arithmetic when solving these problems, since a lot of things are going to be multiplied together, and one very tiny mistake, like dropping a negative or something, can greatly affect your answer. In addition, again, doing the cross product and making sure you're grabbing the right values when you're doing it the determinate way, that can also be very important. So I'm going to have to be extra careful in terms of watching my signs and stuff, but at least I am watching for it, so that's good. In terms of extra resources, there were some YouTube videos that were pretty helpful, especially the organic chemistry tutor. I will promote him any day of the week. And in addition, the physics page at GSU was also very helpful, as it's full of diagrams. In terms of what was the most interesting and related to my major, that would be the multi-particle aspect of angular momentum. If you think about it, molecules are just like particles moving as one system. So finding the angular momentum of a molecule will require an approach like this. There's more stuff too, so it's probably not all of it. But it seems kind of obvious that you would need to use a multi-particle thing if you looked at a diagram, but I still thought it was cool. Anyway, thank you for watching. This has been reading week 13 for Physics 2211, and I hope you have a great day.